Hi, I'm Chem's best friend. I make chemistry easy. I'm a graduate of MIT, and I have more than 17 years of experience teaching AP chemistry and chemistry classes. Please like and subscribe to my channel. And if you are interested in private tutoring lessons, the information is on the screen. Hi, today we're going to keep going with learning about double replacement reactions, especially acid-base reactions and reactions that produce gases. So let's look at my screen. Here is a picture of what happens when you mix acid and base. We have hydrochloric acid and sodium hydroxide, and we mix, and look in the beaker. What do you see? Nothing is going on. When we looked at the videos of double replacement reactions, you see beautiful precipitates forming. But here, looks like nothing happened. So what's going on? Well, let's explore this further. Here's our 6 strong acids. Here's also our 6 strong bases. And when any of them will be mixing together, what will happen? Let's try a pair. Let's pick any 2 pairs. I don't really want to pick hydrochloric acid and sodium hydroxide because everyone is doing that example over and over again. I would like to go to maybe right here, hydrobromic acid and potassium hydroxide. Let's use these 2. So let's draw a picture. So first we have hydrobromic acid, HBr, and the solution looks clear. It looks like water. So we're going to say it's AQ. Plus, what was the base we were going to use? Oh, we're going to use potassium hydroxide. Potassium hydroxide, AQ. And it's our double replacement reaction. So what's the first step? We're going to switch the cations. Let's switch the cations. Here we go. So hydrogen and potassium are going to switch places. And we are going to have, HOH plus we're going to have potassium bromide. Okay, I have to make sure my compounds are neutral. Potassium bromide is +1 for potassium, -1 for bromide. But then HOH, does that seem familiar? HOH? Isn't that water? H2O? Maybe I should erase HOH and just write H2O. What is the state of water? Is it solid, liquid, or gas? It's liquid. And based on our solubility rules, potassium bromide is soluble. So this is going to be AQ. This is why it looks like nothing happened. We had substances dissolved in water, and they formed some new water. We couldn't distinguish the 2. So looking at acid mixing with base, to our eyes, seems like nothing had happened. Now, the temperature would rise. That would be your hint that a chemical reaction is happening. The reaction will get warmer. But just by looking at it, you wouldn't know. Let's draw a cartoon picture of what actually happens to make sure you understand it. So we're going to make our hydrogen with a little tiny black ion. Bromide, let's make it blue. Here is HBr swimming. We have to make our key on the side. Okay, let's make in the second beaker we have potassium. Let's make red. Potassium can be red. Potassium is swimming. And let's make our hydroxide. Hydroxide can be green. Now I am quickly making sure it is balanced. This reaction is balanced. So I don't want you to think, wait, she predicted the states, but there was no step to balance. I did look quickly. The reaction is nicely balanced. Okay, So what happens here? Well, we have our hydrogen. Let's write here. So we have our H plus, and blue is bromide, red is our potassium, and green is our hydroxide. And what's going on after? We formed water. So hydrogen and our hydrogen and hydroxide got together and they were swimming. This, I'm going to say, is my H2O right there. That's potassium and the hydroxide from water. And what do I have still swimming? Bromide is still swimming. And what else is swimming? Potassium is still swimming by itself. Here we go. Let's write our complete ionic reaction to what happened. So we had our hydrogen, then we had bromide in one beaker swimming by themselves, then we had potassium and hydroxide in a second beaker swimming by themselves. And then when the two mixed together, they formed, well, what did our picture shows? H2O is together, and potassium and bromide are still swimming by themselves. So they formed water, liquid, and potassium is still swimming by itself, and bromide is swimming by itself. So what is the same before and after the arrow? Well, we have potassium and bromide, never changed. And this makes sense because when we look at our picture, what's going on? The blue sphere, bromide, was swimming by itself before the reaction. And look at what happened after. Here is bromide swimming by itself after. Let's look what happened at potassium. Potassium is swimming by itself before. And here it is, by itself after. So for them, they were, do you remember what we call them? They were spectators. They just looked and saw the reaction happen. They looked at the players. So these are my spectator ions. And this is my, really fast, I'm going to quickly make a title. This is my complete ionic reaction. Let's actually zoom in on our playing field and who were the players? Which ones, what were the ions that reacted? Our net ionic. Well, we have hydrogen reacted with hydroxide ion, and they formed water. So the net ionic reaction is H plus OH minus making H2O. And here is something you need to know. For any one reaction of your 6 strong acids being mixed with any 6 strong bases, the net ionic reaction will always be this one. It will actually be, for every acid base, will be H plus OH minus forming H2O. There we go. These types of reactions are also known as neutralization reactions. So overall reaction is acid plus base mix water and salt. Water is neutral. It has a pH of 7. That's why these reactions are neutralization reactions. And salt is the ionic compound. Another special type of double replacement reaction that produces gas. So I think it's time to actually see one in action. And let's look what happens when you mix vinegar with baking soda. So let's look at the video. So what do we have? We have some baking soda in a test tube, and we're going to add vinegar to it. And look what happens. Whoa, look at all these bubbles. Isn't that interesting? Let's squirt a little bit more vinegar here, just to see the bubbles one more time. Wow, incredible. This reaction, you can actually try at home. You know, most science videos always say, do not try at home. I think you should try it at home. Not only that, touch it. It will feel cold. So here we had baking soda mixed with vinegar, produced nice bubbles. So what was going on? Well, vinegar is acetic acid. And here is the formula for our acetic acid. So people can write it two different ways. Some people write it CH3COOH. That's a more organic chemist way to show what actually atoms are bonded. Or you can say H for acid with acetate ion. Remember, acetate ion is your polyatomic ion, is C2H3O2. It has -1 charge. So you have acetic acid, and sodium bicarbonate is NaHCO3. When you mix it, they form bubbles and slush. So let's do this. So remember, it's a double replacement reaction, right? Double replacement reaction. So we're going to switch our cations. So we're going to switch the hydrogen with sodium. Let's switch places. They switch places, so let's do that. So we're going to form H. So we will have this H2CO3. And then we're going to have sodium acetate, C2H3O2. And we're going to look quickly based on our solubility rules. Acetates are always soluble, so this is AQ. And this one, this two hydrogens with this carbonate are also AQ. So you say, what's going on here? What's going on here? So we looked at our states. I'm going to make sure that this reaction is balanced. It is balanced. So what's going on? Where are the bubbles coming from? So this is a very special case. We have a double replacement reaction, and then what happens is we're going to take this guy. This guy is carbonic acid. So we have our H2CO3, and carbonic acid breaks apart. It's a reversible reaction. Breaks apart into CO2 gas plus water. Aha! And this is your bubbles, the CO2 gas. This is also a very interesting reaction because if we have CO2 in the air combining with raindrops, you remember some people say, oh, acid rain? What's acid rain? It's carbonic acid. That's the rain. That's the acid rain. So, very, very interesting. So we should quickly talk about what is the driving force of this type of double replacement reaction. Remember, the double replacement reactions that form a precipitate, the driving force was formation of a solid. But here, what is our driving force? Well, in the first example that we saw, any strong acid mixed with strong base, we formed water. The net ionic equation was forming water, forming H2O liquid. So the driving force for these reactions was, let's write this down, was the formation of a liquid. So one of them is formation of a liquid. And the second type of reaction, what happened here? What did we form? We form carbon dioxide gas and we form H2O liquid. So we already have a formation of a liquid, but we also have here, what's the driving force? Formation of a gas. So far, we covered double replacement reactions, all kinds of examples, and we saw that you can form gas. The driving force for reactions are forming of a gas, formation of a liquid, and formation of a solid. We didn't even touch that electron transfer. I guess we have to watch another video and learn more about reactions. So, thanks for watching and see you soon.